Okay, so today we will see the taxiway design. Okay, and and as you know, what is a taxiway? The taxiway is a component of an airport which is provided to access the runways from the terminal areas and from the service hangars, right? And whenever you are comparing the speed of an aircraft which is moving on a taxiway with that of the runway, you can see for yourself that the speed of the aircraft on the taxiway is very less. Okay, and hence the design standards that you should follow while designing the taxiway is entirely different from runway design. Okay, in the previous class we have seen the geometric design of runway, and then we have seen how to apply the corrections uh, for your basic runway length also, right? So today we will see what are the factors, geometric factors that governs the design of taxiway. Though the factors are more or less the same, the standard specifications or the recommendations suggested by ICAO is different. So we need to look into the taxiway design separately. Okay. And before moving to the geometric standards for taxiway, we need to know the layout specifications for the taxiways. Okay. So there are some factors that you should consider while giving the layout of the taxiway. So we have got 5 different factors. First is arrangement. Second factor is whether it is a busy airport or moderate number of uh, air traffic volume is there, then you can decide the fix your layout of the taxiway accordingly depending upon the number of air traffic movements. Then third is crossing. Fourth is high turnoff speeds. And fifth factor is route. Okay. So regarding arrangement, the taxiway should be arranged in such a manner that the aircraft that has just landed should not interfere with the aircraft which is moving ahead to the runway from the taxiway. So you have got two operations taking place, air traffic movements, right? One is takeoff operation and other is landing operation. So the aircraft which has just landed will be moving out from the runway to the taxiway so that they can go to the terminal area, right, to the apron. And again, there will be some other aircraft which is moving from this apron area, and they will be using this taxiway system in order to reach the runway. So if you have provided a single taxiway, the takeoff and the landing operations, okay, the aircrafts will be interfering with the movements. So while arranging the taxiway, you should provide the taxiway routes in such a manner that these interference are not occurring at all. So again, you can provide some taxiway at the exit side of your runway. So as soon as the aircraft land, they can just exit the runway through the help of the taxiway which is provided at the rear end. Okay. Similarly, you can give some intermediate taxiways also, and also one other taxiway at the entry also. So so some of the aircrafts which need to land, sorry, which need to take off, can just enter the runway through this entry point. Okay. And suppose the landing happens like this, then they can exit through the midway. Okay. The middle taxiway which is given in between. So the arrangement should be based on the, again, should be again based on the number of air traffic movements. Then coming to the second factor, that is busy airports. So it is desirable to locate the taxiways at various points along your runway, especially on busy airports. Okay. So you can provide this exit taxiways. So the taxiways which is provided at the exit point of your runway is known as exit taxiways. Okay. So in the case of busy airports, whenever the aircraft is landing, okay, whenever it lands, maybe at this point it will come to a halt. Okay, the landing distance is 60% of the total distance, right? So at this point it will come to a halt, and then it can slowly go ahead and exit the runway through this exit taxiway, and it will be able to reach the apron. Now the third factor in order to decide the layout of taxiway is crossing. Okay, so this crossing occurs in the case of a taxiway, whenever a taxiway and an active runway is intersecting with each other. Suppose in the case of very big airports and all, okay, you may have an active runway, in the sense whenever an aircraft is utilizing a particular runway, at that time that runway is known as active runway. And whenever there is no aircraft which is utilizing, no taking off, no landing operation takes place, then they are not active because it is not being utilized, right? So again, in very big airports, you will find more than one number of runways, and also there will be plenty of aprons. Okay, maybe in this side and other side also you may find aprons. And again, you'll see so many taxiway systems, okay, which connects your apron and the runway, existing runways. And maybe because of this heavy air traffic movement, they will be connecting the two runways with the help of taxiway also. Okay. So in this case, this runway, you can see the taxiway is crossing your runway. Suppose this runway is active. Okay. Then there are chances that if some of the aircraft is approaching this runway, and if suddenly the takeoff or landing process is going on, then it may end up in some drastic collision. Okay, so at any cost you should avoid this type of crossing or intersection. Okay, so it is not at all desirable to provide a crossing or intersection between the taxiways and the active runways. So instead of giving a crossing or an intersection just like this, you can provide some other route for connecting this runway to the apron. Okay. Now the next point is high turn off speed. So if suppose we have mentioned about the exit taxiways, which helps the aircraft that has just landed to get in order to exit them from the runways, they can make use of the exit taxiways, right? So if you are providing or designing this exit taxiway in such a manner that if they can cater high speed aircrafts, okay, higher speed aircrafts, then it will help in reducing the runway occupancy of the landing aircraft. Okay, so those aircrafts which is just landing, okay, can exit through the exit taxiways. So if those taxiways can cater higher speeds of the aircraft, or it is also known as higher turn off speeds, okay, higher turn off speeds, turn off is used because the aircraft is turning to the exit taxiway. Okay, so this higher turn off speeds are always referred to these taxiways. So when without reducing their speed, if they can just exit from the runway through this higher turn off speeds, through the taxiway which is designed for higher turn-off speeds, then this will reduce the runway occupancy of landing aircrafts. So as soon as the aircraft is coming over this runway, they can turn off to the taxiways. So the time duration by which these aircrafts are there on the runway is reduced, so that more number of aircrafts can be utilized, can make utilize of that runway. Okay. But if you imagine that if the taxiway is not designed for higher turn-off speeds, then your aircraft will be landing after 60% of the distance. It will come to a halt. Then it has to accelerate. Then it has to maintain its speed, reduce its speed. Then only it will be able to exit from the taxiway. So till that time, if some other aircraft is there in the queue, maybe taking some circling movement above the airfield, so that aircraft have to wait, right? Because unless otherwise this aircraft which had just landed is moved from the runway, the other aircraft won't be able to land. At the same time, if you have provided higher turn of speed taxiways, then soon after landing, it can just, okay, move to the taxiway without taking a stop position, but it has reduced its speed. Okay, so a lot of time is saved by providing higher turn of speed taxiways. So this will finally help you to reduce the runway occupancy of the landing aircraft. So more number of aircraft can utilize runway within shorter time period. And the last one is route. So whenever you are laying out giving the layout of your taxiways, always try to provide the shortest route possible. Okay. So if you have runway over here and this is your apron, so this is the shortest path, right? Okay. And no need to provide again taxiways from the other end, or else you can just give a diversion over here. So instead of this, you can go for this path, right? So a bifurcation is given from here. And again, you need not give from here. The shortest path can be provided. So that at the entry point, you are giving a taxiway, exit point, and in between, Middle point also you are giving taxiway. And also, if you need, you can construct a parallel taxiway system, okay, parallel system, and you can just connect the aprons with this parallel taxiways. And again, you need to connect it with the runways, different points. But make sure you are providing the shortest possible path because it could save a lot of your fuel also. Okay. So these are the five factors that you should look into while laying out the taxiways, arrangements, busy airports, then crossing, higher turn off speeds, and finally the routes. Now let's move to the geometric standards for taxiways, geometric design standards. So, like runways, here also we have got 8 elements. Okay. So the first one is the length of taxiway. I'll just list out the 8 different elements today, and we'll discuss it in the next class. Okay. Next is longitudinal gradient. Third is rate of change of longitudinal gradient. Fourth one is side distance. Fifth one is transverse gradient. Sixth is turning radius. Seventh is width of safety area. And finally, width of taxiway. So these are the different geometric standards, different elements, okay, different elements for the geometric standards of taxiway. Length of taxiway, longitudinal gradient, then rate of change of longitudinal gradient, side distance, transverse gradient, turning radius, width of safety area, and finally the width of taxiway. Okay, that's it for today.